the highest exponent is 3.
Okay, so to start off, we have to figure out what kind of function this is. And based from what we see here, it is a rational function. And it can also be written in the form here. F of x is equal to 2x equals 3 plus x squared, since it's much easier rather than using t and c. So this is the equivalent rational function of this. So they're the same. And in every rational function, there is usually asymptotes. So to find the vertical asymptote, we just have to equate this denominator. So we're gonna have to equate it to 0. So let's remove this first. Then let's draw 3 plus x squared equal to 0. So x squared equals negative 3. This isn't really possible, so x is equal to 0. So we don't have any vertical asymptotes. No VA. Next, we have to solve for the horizontal asymptote. Horizontal asymptote, we have to look at this and this, the one with the x's, and we're gonna divide since the denominator has a bigger or higher exponent. So what we're going to do is we're going to do 2x over x squared equals, now we're gonna divide both by x, so 2 over x. And this isn't really a solution or anything like that. So basically our horizontal asymptote is also 0. So now we're gonna move on to the x-intercept, and to get the x-intercept, we need to make the numerator equal to 0. So this is the numerator, 2x. And now we're just gonna do 2x is equal to 2x is equal to 0. So x is equal to 0. So our x-intercept is 0, 0. This is the form x-intercept. And obviously if we have an x-intercept, we also have a y-intercept. So for our y-intercept, all we have to do is let x equal to 0. So all the x's we have in the function would be substituted, and then it will turn into x. So first is f of 0 equals 2, 0, 3 plus 0, 2. 0, 0. So we also don't have a y-intercept. It's also 0, 0. So that's that. Okay, so now we're gonna assign points to be able to graph it after this. So let's just assign values that are near to 0, because this is already a point that we have from what we solved earlier. So let's do number 1 and negative 1. Okay, so for negative 1, 2, then 3 plus negative 1 squared. So that would be negative 2 over 3 plus 1, negative 2, 4 equals negative 1 half. So negative 1 half. Then now we're going to move on to 1. So f of 1 equals to 2 times 1 3 plus 1 raised to 2. So that's equal to 2 over 3 plus 1 equals 2 over 4 equals 1 half. So now that we have that, we have our table of values. We can go and graph it, but in this case, I'm going to use Desmos Graph. It's a website so that the points are more accurate. Okay, so to properly show the graph, I input it in this website called Desmos Graph, and it is also based on the points that we did earlier. So based on this graph, our domain is negative infinity to positive infinity, since as you can see, it's pretty long, like further there to the left and right. So that's for sure negative infinity to positive infinity. And then our range would be negative infinity to 0 union 0 to positive infinity. And that's because this point, they meet at 0, 0. And after 0, 0, they either go up more. So that's why there's a union, because also we have our vertical and horizontal asymptote which affected this. That's why we have a union. So yeah, this is what the graph looks like. So just a refresher to all the values that I solved for earlier. Our domain is negative infinity to positive infinity. Our range is negative infinity to 0 union 0 to positive infinity. Our vertical asymptote is none, and our horizontal asymptote is 0, y equals 0. And then our x-intercept and y-intercept are both 0, 0. So that's it.
Hello, good day everyone. First, do you know what type of function this is? P of t equals 335 times e raised to the power of 0.05t. This equation is an example of exponential growth. It is based on the formula for exponential population growth. P equals p sub 0 times e raised to the power of rt. P means total population after time. P sub 0 means starting population. R means rate of growth. T means time in hours or years. E means the Euler's number. Before I dive into this equation, let me explain the exponential growth function and where it applies in real life. Exponential growth function is a quantity that grows exponentially if it increases by a constant factor or at a constant rate per unit of time. We often use exponential functions in scenarios such as modeling population growth in cities, wildlife, or bacteria, or calculating compound interest, or determining doubling times. Now, let's dive into the equation. The domain of all exponential function is all real numbers. Therefore, this function domain is from negative infinity to positive infinity. Meanwhile, the range of the function is all real numbers greater than 0. Therefore, this function range is from 0 to positive infinity. Now for the x and y intercept. Fortunately, there's no need to find the x-intercept since they don't exist for this equation. Exponential functions like e to the power of x never have an x-intercept because they never touch or cross the x-axis. As the value of x becomes more and more negative, the function gets closer and closer to 0, but it never actually reaches 0. So there is no x-intercept for this function. Meanwhile, the y-intercept is the point where the graph of the function meets the y-axis, which happens when x equals 0. The y-coordinate at this point is the value of the function when t equals 0. For this function, when t equals 0, the value is 335. So, the y-intercept is 335. Next, the horizontal asymptote of this function is y equals 0. Because as x approaches negative infinity, the function's value gets closer and closer to 0, but never actually reaches it. However, in exponential functions, the horizontal asymptote can change due to transformation of the function. Next, there are no zeros for this equation because the output of e raised to the power of 0.05t is always positive, meaning p of t is greater than 0 for all values of t. To visualize all of this, let me show you the graph. Seeing the graph alone, you can see that it is increasing. However, how do we know this just from seeing the equation alone? Basically, if k is greater than 0, the function models the growth of an entity. However, if k is less than 0, the function models the decay of an entity. In this equation, the exponent k equals 0.05 is positive, meaning the function increases over time. The initial value of 335 is greater than 0, ensuring that the function always stays positive and never goes below 0. If the exponent were negative, the equation would model exponential decay instead. The rate of change in this equation is determined by the exponent k equals 0.05, which means the value of p of t grows by approximately 5% per unit of time. Now, let's try to solve the equation using the Gressa method. Here's the problem. We want to analyze the population growth of the red-vented kakadu, which was estimated to be around 335 in 2019. Their population has been growing at approximately 5% per year. If there are no external factors affecting the population, what could we expect the population of these red-vented kakadus to be by 2024? Therefore, the population of the red-vented cockatoo is expected to be approximately 430 individuals by 2024, assuming a steady growth rate of 5% per year. Okay, now you might ask, does this equation have an inverse? The answer is yes. Exponential functions are one-to-one functions, and all one-to-one functions have inverses. The inverse of an exponential function is also a one-to-one function. And let me show you how. And there you have it. To confirm this, we could do the substitution. Now, let's dive into the equation. The domain of the original function becomes the range of the inverse function, and vice versa. Therefore, the domain of the inverse function is from 0 to positive infinity, while the range is from negative infinity to positive infinity. Next, the vertical asymptote for the inverse function is at x equals 0. Additionally, the x and y-intercept change. The x-intercept of the inverse function is now 335, while there is no y-intercept. For more visualization, here's the graph. As you can see, the graph of the inverse function is also increasing. And there you have it. That is the exponential growth function. I really hope you learned something from this video, and I'm excited to see how you will apply this in your life. Thank you.